Hello guys, um, welcome to this project discourse, and we're going to be talking about how to create and deploy big data jobs on AWS EMR. That's the AWS Elastic MapReduce, and we're going to be using Spark. So the Spark tool on AWS EMR. AWS EMR has many tools. It has Spark, Hive, Presto, uh, Scoop, and so many other big data tools. So, but we're going to be using AWS EMR. We're going to be using Spark for this particular project. Basically, what we have here, the use case is a growing streaming startup, and it has its user base and song library, and he stores this data in S3 JSON format. So and the company now wants to use it for analytics. He wants to do some pre-processing on it. Structure it into a relational format, and more of using facts and dimension models. So yeah, tables about using facts and dimensional models. So what this project is going to do is we're going to see how to deploy an ETL job. It's ETL job, data job, Spark job. I'm going to be using them interchangeably, and this job is going to read data from S3, then process them. He's going to process it using Spark, then loads it back into S3 as a set of dimensional tables. So we're going to be the tools, AWS EMR service, Spark, Bash, Python. We're going to be using AWS CLI. So it's going to be on command line. So and you need Bash commands, as well as we're also going to deploy with Python. So this is it. Set up your cluster. We're going to set up a cluster. We're going to see how to write transformation. Then we're going to deploy that transformation to Spark via console. We're going to deploy via command line, and we're going to deploy via using the SDK. So the data set, a million song is what it looks like. This is a fictional data set, so freely available collection of metadata. So we were using two sources, this and this is an event data, a for testing and demo purposes. So it just generates big data that links this. So it's written in Scala. So yeah, I'm gonna put a link. The link is in the blog. So yeah, yeah. I think so. Next, we create a cluster. So we are in AWS EMR. You can see the big data tools that you can run. We're going to be creating clusters first of all. So you can see previous clusters I've run, I've created in the past. I can either clone the configuration so I don't have to configure it again, or create from scratch. So maybe I just want to do something new. So for this, we'll be doing that. and we're going to name our cluster data cluster. Pick a version. There are different versions. It's best to pick, around the latest stable versions. So there are different tools, like we said, Adobe, but for this we're going to pick Spark, and it comes with the different applications that run with Spark. And then what we're going to use here, Adobe Jupyter Enterprise Gateway. We're going to use the Jupyter Notebook. So we go to the cluster, and we pick a cluster. There's a primary, core, and task. Primary is the driver. It assigns the task to the core, and also task as well runs runs the job. This primary doesn't run any job. It manages the resources. On primary you have things like yarn installed on it, and Spark driver and other things you need. While core, you have the Spark executor on core. You also have the Spark executor on task, and they can process partitions of data distributedly. That's the advantage of Spark. Basically helps you process data in parallel, by running on multiple systems connected in the network. So there's a network connecting all these clusters that the driver communicates and manages the task. So we pick a size. For this primary we don't need so much, so I think M4 large, yeah. And for the core, M5, that's the 4 virtual CPUs, and then 16 gig memory, 16 gig RAM. um, so 15 gig root, that's a 15 gig disk storage, throughput, and IO per second. That's the input output per second. So this is a summary of what we picked. For this you can pick the network, that's the VPC and subnet. Subnet, yeah, if you have created an existing subnet you just pick it, or you create one from scratch. Basically, geographical locations that run these programs. So step you can deploy. Step will come back to step. We can deploy a job using step. Cluster termination, automated. You can set it after completing a task, or maybe after a period of time. Cluster logs, task. Bootstrap, maybe you want to install a special package that is not already installed on the cluster you have now, so you do that with this. So normally your requirement.txt file will come here. And easy to keep here. If you want to log into the cluster, you want to tunnel into the cluster with SSH, you just have your key pair, and but for this we're just going to be using the console, the CLI, the AWS CLI, so we don't have to SSH into the cluster. And you pick your default role. Normally default role works, except you need some special requirements, so in this case you don't. You can even move tasks because we are not running so much data, so that we can manage cost, and we create our cluster. So starting, we can see all the information, all the data, all the details uh, right here. So normally it takes about 10 minutes for the cluster to complete, to to be to be ready to finish startup. So we wait. So we can see it's in waiting state. That means it's ready, and it's ready to receive the jobs. So to do that, we go to EMR. We are first of all using notebooks. You have to create a studio. So you just do this and select all the options and create a studio. Then you create a notebook. So, but we already have an existing notebook. What we do is just attach a cluster to it, and the security group, the default. And then we launch. So we can see Jupyter Lab. Remember we installed Jupyter Lab. Yeah, so we're going to see the code now. This is the Spark job. It contains your transformation logic, where it reads data, transforms, then loads back your ETL process essentially. And we can see the libraries are imported. We can run them in fact and see how it starts. So it takes a little while. I mean, it, okay, so this is it now. Spark, you import all the libraries, and Spark is initialized. The first cell that is run in the Jupyter notebook initializes Spark. Then you create your Spark session, which is your context, your transformation context. Then you can see the data. Data is stored in EMR. If you want to see, um, so this is where the data is stored. Some log data, and they are just JSON files, many JSON files, and you import, you assign the variable, the path, then read it, then you see data is being read. It's just kind of managing a task. This EMR has this visual display. It's Jupyter Notebook actually has this visual display of the progress, and we can see the data here now. Shows data, some data to show the what the data looks like: artist, latitude, longitude, name, duration. So from that millions data now, you see that we are selecting the different fields we need, job duplicates. Then this is what data looks like now, the song table. Then what we want to do is we want to write. Then we write or partition by year and artist. So when you write, the way the data is partitioned, it enables easy retrieval. See year, and for each year there's an artist ID, and you can see a partition of the file. So we do the same for artists, and we view the data the same for we ingest the log data, you know, look at the columns, look at the sample where it looks like this is the event data, the user events data from that event scene earlier. It just shows you user events, and you want to get where df log equals next song, the next song played by users, and it gives you all this information. And you can process data, select what column you want, and write. This is the time. The time. This shows the time dimension. Remember, we're talking about facts and dimensions, so we are going to have different dimension tables about the users, the songs they listen to, and the time period, all those information. You see that this is written out to S3. So this is a summary of all the console, and once you run all this, you will see that you will see your data, see all the data written into S3. These are dimension tables that you can then now read into your SQL database, or you use Athena to read the files. Athena just allows you. Athena is Presto, which you can interact with this data. So yeah, that's that's what it is. That's how to process data with console. And some people might be okay with, oh, the work is done, it's a one-time thing. But if you want to deploy on a schedule, you can't use a Jupyter notebook. You need a script, a deployable script. So you can either write a Python script or a Java script. Or a Java, not Java, JavaScript, a Java program, or a Scala program, because Spark only works with Python, Java, Scala. So those are the client libraries it works with. So this is everything about the using the notebook. So next we're going to look at how to convert this script to a modular uh, script that can be deployed. And basically it's going to be a script that we can submit. This is exactly the Spark submit script. The cluster just takes the script and runs it. We can see similar to what we looked at, the data, the transformations, writing to S3. See process log data, same thing. So we have the dimension tables written to S3, and typical Python main function for running Python scripts. So once you have that, once you have converted it like this, the next thing you do is you deploy to the cluster. And to do that via the console, there's something called step. Step is basically you can add a series of jobs to the cluster and it will execute it for you. So we can see Spark application. What we're going to do is this script. We're going to we've uploaded it to EMR, I mean to S3. So we have the script. This is the script right here. This is the script right here. Cluster mode is for production. Basically, for let's start with client. For client, you connect to the client cluster and you submit the script. So, but since we're using S3 now, everything it's not really so important. But imagine you are testing and you are connected to the primary cluster directly. You would, you are communicating with it. You copy your script to the primary cluster, and the primary cluster is going to distribute the task to the worker cluster as the core and the task as the case may be. So but the thing is you can disconnect and and leave the job to run with cluster mode. But with client mode, client mode is for development mostly, and once you disconnect from the cluster, it it stops whatever process around it stops. So but in this case now, we are going to choose cluster mode because we just want to leave it and come back while it runs and finishes. So we can see it running now. This is how to deploy Spark job via UI, via the console. So we can see here now the job is completed. There are no errors. If you were to run this directly on the Spark driver, the primary cluster, this is the command you run: Spark submit, then this config, this argument, and that is how you deploy a Spark job using the console. Next, we go to the next we use the CLI. So this is basically creating a Spark cluster using AWS command line, and this is the command I used to create an EMR cluster. You can see this is an evidence that the cluster has been created. if we go to EMR, we're going to see EMR cluster starting. You can deploy a cluster independently, or you can deploy the step with the cluster. So once the cluster starts, it runs the step immediately, or you can add the step after starting. So we can see that our cluster is ready after using the CLI command. It's just as simple as running this, and here you have it. So next thing is we add a step to our cluster, and what we need to do is we need to get the cluster ID. Get the cluster ID and replace it, put it in the CLI command. So all the configurations, this is where you find it. You put it here, or this is the cluster you want to deploy to, and you execute. So you see we have our step ID. It shows that the step has been added. You can see now. If you have another script, we can add it again, but we just add the same just to see that we can deploy multiple steps, and it's just going to run it. If you are working with multiple different kind of data, different sources, you can have that multiple steps here. And CLI is pretty straightforward. Deploying Spark jobs via CLI is pretty straightforward. So we're going to come back once it's done. So the job is complete. The ETL job that we modularized in the deploy script has been deployed successfully and without errors. So that's all about deploying with CLI. So next we check out how to deploy with Python, and just looking at it, we're using the Boto3 library. The Boto3 library is an AWS SDK that allows us to connect to AWS and deploy resources, interact with resources. So we can see create session, then EMR clients, select EMR clients, define the S3 configurations, then the client uses this run job method. We specify the different arguments, and see the cluster name, version, the nodes. You can see core node, master node, then the applications we want Spark to be installed on it, add other applications we want. Then can also add the step. So once the cluster finish creating, it deploys the job almost immediately, and the roles, the permission we have here. So we can, after creating a cluster, we can add a step just like the CLI independently. We can add a step to the cluster and it will run. So this is what the Python deploy script looks like, and we just simply run Python deploy, and it's, you see, created. Check this out here. You see that another cluster is starting up right now, and we see the same thing, how it processes the step and deploys it. That is pretty much it about creating and deploying big data jobs on AWS EMR with Spark. So I hope everybody that watched this video will learn, and you can check out the blog. It contains everything in details. You can take your time and go through it and check out articles as well. So yeah, subscribe, share and subscribe. Thank you guys.